Next, we are going over factoring. In order to know what factoring is, we need to remember what distribution looks like. Distribution starts like this, and then we end up multiplying. 3 times 2, that gives us 6. And then we multiply the 3 with the 3x, and that gives us 9x. So in distribution, we start with this, we end with this. In factoring, it is the exact reverse process. So we're actually going to start with problems like this, and then we are going to factor it so it looks like this. Okay, and part of the reason why it's called factoring is because the number that comes to the outside right here, this 3, that is a factor, specifically the greatest common factor of 6 and 9x. So we will be going over how to turn this into this. So factoring is the opposite or reverse process of distribution. So we are going to go over how we actually did this process. Okay, and the way that we do that is using the GCF, the greatest common factor. So take a moment to copy these steps down. Okay, this is quite procedural. And so step 1, in order to factor this to look like this, is we need to find the greatest common factor. So let's go ahead and do that. We're going to use the tree method. So we have 6, we have 9x. We know that 6 is 2 and 3. We know 9x, that's 9 multiply x. And then the 9 is 3 and 3. So the 6 written out is 2 times 3. The 9x written out is 3 times 3 times x. We find what is common, so our GCF is 3. Okay, so that's step 1. So step 2 is to separate this using this GCF. So we separate the 6 with the 3. We have 3 times 2. Okay, I'm going to circle this so we remember that's the GCF plus, and then we break this down using the GCF also. We think 3 times what number is 9? That is going to be 3 times 3x. And you will notice that this number right here is also this number here. This number right here are these terms right here. So that is step number 2. And then step number 3 is we actually take this GCF, the 3, and we take it out, just like we drew the arrows on distribution. So these 3 combines to make just one single 3, and then what's remaining on the inside is the 2 plus 3x. And there is your answer. So one way to check if this is correct is to go ahead and distribute it. Because when we multiply 3 times 2, we get 6. 3 multiply 9x. And since we got the same answer that we started with, we know that this is our correct answer. Now we're going to factor 8 plus 12x. Okay, and so let's go ahead and break down this 8 following the steps from above. So this 8 breaks down to 2 and 4. Break down this 4 to 2 and 2. 12x, 12 times x, 4 times 3, 2 times 2. So we go ahead and find the GCF from here. And so we know that the 8, 2 times 2 times 2, the 12x, 2 times 2 times 3 times x. We see here that we have 2 2's that are common to both, so that means our GCF is 2 times 2, which is 4. So step number 2 was to separate these using this GCF. So this 8, we start with that GCF, times 2 is 8, plus bring down that GCF again because we're separating this 12x, and that 4 multiplies by 3x to get 12x. Once again, these numbers also come from here. This 3x also comes from here. Our last step is to take that GCF of 4 out and put it in front of the parentheses, leaving these inside. There we go. And then you can check your answer if you'd like. Our last example, 12 minus 15x. We break this down. We have 2 and 6. Then we get 2 and 3. 2, 2, 3. We get 15 times x. 3 times 5. So GCF for 12 and 15x, we find 3 is common to both, so our GCF is 3. We break down the 12 using this GCF, so we have 3 times 4 becomes 12 minus, then we break the 15x up into 3 times 5x. Once again, these terms also come from here. We take this 3, pull it out front, we leave these numbers inside, and there is your final answer.